So good day. When multiplying by polynomials, we end up in an area that we call special product multiplication. And so one of the things we want to do is we want to become more efficient with our algebra. In other words, we essentially want to start doing things more mentally and more efficiently so that we can move through the algebra quicker and arrive where we need to be faster. Now, this all takes practice. You have to practice with it over and over and over again. And so we're going to talk about several special products today. First of all, we're going to talk about how to multiply binomials, and then we're going to talk about three special forms, a binomial squared, and then also a difference of squares, and we'll talk about those and how to do them. So let's get started. The first method we're going to talk about that's really a little bit mental and makes us more efficient is the FOIL method. It's a way to do distributive property in your head. So let's give you a quick example. 2x minus 3 times x plus 4. And what do we do on the FOIL method? Well, we do these multiplications. I actually draw it with diagrams. We do the first multiplication, which is 2x times x, or 2x squared. And then we do the outsides, which is 2x times 4, so I get plus 8x. And then we do the inside multiplication, which is negative 3 times x, or negative 3x. And then we do the last in each binomial, negative 3 times negative 4, which is negative 12. At this point, all we have to do is collect like terms. 2x squared, and then 8x minus 3x are the only like terms, so that's 5x minus 12. And so this becomes an efficient way to do the distributive property. It really skips the step where we go 2x times x plus 4 minus 3 times x plus 4. Oops, 4. It really skips that particular step, and by allowing us to do the multiplications more efficiently. So this is an efficient way to do multiplication. All right, why don't we try an example? I'll leave this up here, and let's have you try one. Alrighty, try this one right here. 5 minus 3y times 6 minus 2y. Ready, set, pause the video. Okay, here we go. Let's go back and do. Okay, you're back. Here we go. Let's do FOIL. 5 times 6 is 30. 5 times negative 2y is minus 10y. Negative 3y times negative 6 is minus 18y. And negative 3y times negative 2y is plus 6y squared. So all the multiplications are done. I collect the like terms. 30 minus 28y plus 6y squared. All right. So you got to always keep addition and multiplication separate. When you multiply y and y, that's y squared. But when you add y and y, that's still just a y. Okay? Why is that? Think about adding 3 hot dogs and 4 hot dogs. You get 7 hot dogs, not 7 hot dogs squared. That's kind of a good way to remember it. All right, let's go on to the next idea. So the next thing is what we call special products. And these special products take the following forms. A plus B times a plus b, which is equal to a plus b squared. And so you'll see it in either way. And then you have a minus b times a minus b, which you'll often see as a minus b squared. And then finally, the last one is where you have a plus b times a minus b. And that's how you'll see that. So when you see these forms, either written as two multiplied binomials or squared binomials, or you see two binomials multiplied with opposite signs, then these are called the special products, and these are really memorized forms. And to memorize, you need to practice over and over. Okay? So let's take a look and see what happens with these forms. All right? So we're going to start with a plus b times a minus b. All right? And of course, it could be written as, you could have a minus here and a plus here. And that would be okay. This one has a name. It is called a difference of squares. And it is named after the result. Okay? It's named after the result. If we multiply these out with FOIL, what we end up getting is we get a squared plus ab minus ab minus b squared. And so the plus ab minus ab, the like terms we collect, add out, and we end up with a squared minus b squared. Hence the name difference of squares. This only occurs when you have opposite sign binomials multiplied times each other, a plus b times a minus b. Okay? This is the only time it occurs. This is what it looks like. All right? This will show up again and again and again. It's really a shortcut form to simplifying lots of things. So let's look at a quick example. If I see like x plus 3 times x minus 3, like that, right away I recognize it's difference of squares, so I know the answer is x squared minus 9. That's sort of the goal. We want to be able to get there. When I see the pattern, I can write it as the first term squared minus the second term squared. All right? And if I see that, then I recognize the pattern, and I can do that over and over and over again. Let's show you a couple more examples, a couple more quickies, just for how it can be different. You could have something like this. You could have y squared plus 2y times y squared minus 2y. And you go, oh, that's a plus b, a minus b. Therefore, that's going to be the y squared squared minus the 2y squared. That's a squared minus b squared, okay? But y squared squared is y to the 4th, and 2y squared is 4y squared, because it's 2y times 2y. And so that's how that multiplies, okay? And so if you can recognize this right off the bat, you should be able to write this, but you might need to write this in between step if you have extra coefficients and extra exponents that you got to keep track of. But still, you just write the first term squared minus the second term squared, okay? Alrighty, let's move on to the other ones. So the other ones take on problems that look like this. X plus 3 quantity squared. Now, in general, whenever I see a quantity squared, I just write x plus 3 times x plus 3. And then I would use the FOIL method, and I would multiply this out. Squared plus 3x plus 3x plus 9. So we end up with x squared plus 6x plus 9. And so what I notice here when I see something like this is I can see a pattern. I see that the first term gets squared. I see that the last term, the 3, also gets squared. But what I also see is that we have to multiply the two things together and then double it to get the middle term. And this turns out to be what the pattern is. If you have a plus b squared, it's equal to a squared plus 2ab plus b squared. And so the goal is not to do this by FOIL. It's to recognize the pattern and then just write out what the solution is. So let's do a quick example of what that's going to look like. Let's try and do this one. Let's do okay. Now, I should mention, let's make it 4y plus 5, and then I can mention that on the next slide. So 4y minus 5 squared. So what I notice is that this is an a plus a b quantity squared. That means the result should be a squared plus 2ab plus b squared. So a squared, that's the 4y, that's going to be squared. Okay. The b squared is the 5, and that's going to be squared. And then I have to add 2 times the a times the b, which is 4y times 5. All right? And so I can write it down in this way and get 16y squared plus 40y plus 25. And that would then be the correct multiplication of this. And I can do that without turning it into FOIL. Now, if it confuses you to try and figure this out, my suggestion is you do it by FOIL and get it right every time. What's more important is that you get it right every time and that you don't start practicing a wrong way. Now, if you remember, in class, we talked about a problem like this that showed up on a previous assignment. And somebody said, why is it not 16y squared plus 25? And that has to do with the fact that when you do the multiplications, you end up getting 5 times 4y twice, or 20y plus 20y. And so you want to make sure you remember those, and that's the 2ab. See, here's our 20y, and then we double it to get 40y. Okay? So let's do another problem really quick. All right, next problem would be, let's do 2y plus 9 squared. Okay? So when I see that, I go, oh, it's the first term squared. 2y times 2y is 4y squared. It's the last term squared, plus 81. And then it's the middle term is 2y times 9, 18y, and I double that, so 36y. And that's how I do the problem. And I can mentally multiply that if I know my times tables fairly quickly. And this works with fractions and everything else as well. Okay? Let me give you, should I do one with fractions? Yeah, we probably should. Let's try that. Here's a fraction one. Let's go with 3y minus 1/4. or plus 1/4 squared. So that I recognize the pattern, a plus b squared. So it's going to be a squared plus 2ab plus b squared. So a squared is 3y times 3y, or 9y squared. B squared is 1/4 times 1/4, or 1/16. And then the middle term is 3y times 1/4, which is 3/4 y. And then I double that, so that'll be 6/4 y, which will simplify to 3/2 y. So now I can simplify that in my head. You might not be able to, and you might put 6/4 y after you double it, and then you might go, oh, I can reduce that fraction, and that's fine too. Okay, there you go. That's how you multiply special products. I do want to mention one thing. The name of the a plus b squared is called a sum squared. Okay, it's a binomial, and you could say it's a binomial sum squared. All right, because we're adding two things, so it's a binomial, two things. All right, and you square it. Well, guess what? You can have a binomial difference, a subtraction squared as well. But when you square that, you just get a squared minus 2ab plus b squared. That's the formula. Why do you get that? Well, a minus b times a minus b is equal to a squared minus ab plus b squared. And that's a squared minus 2ab plus b squared. So now we know that the formula makes sense, and we have to practice with the memorized formula. So an example would be like this. We could have x squared minus 5 squared. And I go, oh, that's an a minus b. And so my solution is going to be a squared, x squared times x squared, which is x to the 4th. A times b, 5x squared, double it, and it's a negative, so minus 10x squared, and then square the 25. And so there's the solution, following the pattern. And so once you really learn the pattern, you become more and more efficient. Now I do want to mention, before I close this video, there are a couple of interesting problems I see. One of the things that we'll notice is when you do geometry of a square, if the sides of the square were like x plus 2, all right, then the area of the square would be a binomial sum squared. So this happens a lot in geometric things because squares exist and things with equal sides. And so when you start to compute areas, if they're algebraic, what happens is you end up with these binomial sum squareds. Okay. The other thing that happens in the further exercises is they sort of make the problem slightly more challenging with these things. So for instance, you might have something like this, where they have a 2x plus 3 times a 2x minus 3, and then the whole thing is squared. So when you think about that, you go, okay, inside here is a difference of squares. So I can just write that as 2x squared, which is 2x times 2x, 4x squared minus 9. It's a difference of squares. And then I have to square that. Now it's a difference squared. So the formula is a squared minus 2ab plus b squared. Whereas here I used a squared minus b squared to do the inside. So now I'm going to square this difference, and so I want to square the 4x squared, so that becomes 4x squared times 4x squared, or 16x to the fourth. And then minus, I take 4x squared times 9, which is 36x squared. And then double it, so minus 72x squared. And then I square the 9 and get plus 81. And so now I've done this problem using 2 memorized forms, and I can do it in just 2 steps. But you've got to practice with the forms so that you memorize it. Okay? So these are some clever multiplications that occur, and I'll be assigning a couple others to you to look at. And we'll see how you like it when it's done. Okay. Alrighty. That's all I have for you in this video. We'll see you next time. Bye.